The ocean, in all its vastness and beauty, holds a power that can be both awe-inspiring and terrifying. Few phenomena demonstrate this duality as dramatically as the tsunami. Imagine a wall of water, towering dozens of feet high, crashing onto the shore with unimaginable force. This is the destructive reality of a tsunami, a series of ocean waves generated by a sudden displacement of water. Unlike typical waves driven by wind, tsunamis are triggered by seismic events that unleash colossal amounts of energy into the ocean. These events can displace immense volumes of water, creating waves that travel across entire oceans at incredible speeds. While tsunamis are relatively rare, their potential for devastation is immense. Understanding the science behind these natural disasters is crucial for mitigating their impact and protecting vulnerable communities. The Earth's crust, far from being a solid shell, is a dynamic jigsaw puzzle of tectonic plates in constant motion. These plates grind against each other, building up immense pressure over time. When this pressure exceeds the strength of the rocks, it is released in a sudden, violent rupture, an earthquake. Undersea earthquakes are the most common cause of tsunamis. The seabed's vertical displacement during an earthquake acts like a giant paddle, displacing a massive volume of water and generating a series of powerful waves. The energy released in these earthquakes is staggering, capable of creating tsunamis that can travel thousands of miles across the ocean. While undersea earthquakes are the primary culprits, other phenomena can also trigger these monstrous waves. Underwater landslides, volcanic eruptions, and even large asteroid impacts can displace enough water to generate a tsunami. Imagine tossing a pebble into a still pond. Ripples spread outward from the point of impact, losing energy as they travel. Tsunami waves, while similar in principle, operate on a vastly larger and more destructive scale. When an earthquake or other event displaces a large volume of water, it creates a series of waves that radiate outward from the source. These waves travel at incredible speeds, often exceeding 500 miles per hour in the open ocean, as fast as a jet airplane. In deep water, tsunami waves are barely noticeable. Their wavelength, the distance between crests, can be hundreds of miles long, but their wave height is often just a few feet. As the waves approach shallower coastal waters, however, something dramatic happens. The shallower depths cause the waves to slow down and bunch up, dramatically increasing their height. This phenomenon, known as shoaling, transforms the once inconspicuous waves into towering walls of water that can inundate coastlines with devastating force. Section 4. Nature's Wrath. Tsunamis' Impact on the Environment and Humanity. Tsunamis are a force of nature that can reshape landscapes and devastate communities. Their impact is both immediate and long-lasting, affecting the environment and human life in profound ways. When a tsunami strikes a coastline, its sheer force can obliterate coastal ecosystems. Coral reefs, mangroves, and other vital habitats are destroyed, leaving behind a trail of ecological devastation. The immense volume of water carries debris, pollutants, and even marine life far inland, contaminating freshwater sources and disrupting ecosystems. For human communities, the impact of a tsunami can be catastrophic. Buildings, roads, and infrastructure are no match for the destructive power of these waves. The loss of life can be staggering, with thousands or even hundreds of thousands of people perishing in the most severe events. The economic toll is equally devastating, as entire industries and livelihoods are wiped out. The psychological scars of surviving a tsunami can linger for years, a testament to the trauma inflicted by these natural disasters. Section 5. Remembering the Waves, Historical Tsunamis and Their Lessons. History is replete with examples of devastating tsunamis that have left an indelible mark on human memory. The 2004 Indian Ocean tsunami, triggered by a massive undersea earthquake, was one of the deadliest natural disasters. Tsunami waves devastated coastlines, claiming over 230,000 lives in 14 countries. In 2011, the Tohoku earthquake and tsunami struck Japan, causing widespread destruction and over 15,000 deaths. These events have provided invaluable lessons about tsunami behavior, early warning systems, and disaster preparedness. Section 6. Towards a Safer Shore, Early Warning Systems and the Importance of Preparedness. We cannot prevent tsunamis, but we can mitigate their impact through advanced technology and preparedness. Early warning systems and effective evacuation plans are crucial for reducing the human cost. Modern systems rely on sensors, buoys, and seismic stations to detect tsunamis in real time. These systems provide valuable warning time, allowing for timely evacuations. Public awareness and education are equally crucial. Recognizing warning signs like a receding shoreline can mean the difference between life and death. Coastal communities should have established evacuation routes and safe zones. Preparedness includes having emergency kits with essential supplies. Proactive steps can reduce risk and build resilient communities.